Physics 2 Lab 1, Charged Tapes. The purpose of this lab is to determine the amount of excess charge on one piece of clear tape. In order to accomplish this goal, we will need to use tape, a ruler, and two objects on which to suspend our base tape. Additionally, we will use GlowScript to create a computational model that will calculate our model and results. For a quick preview of results, the charge of each piece of tape is equal to 3.765 times 10 to the negative 9 coulombs, and the number of electrons lost by each piece of tape is 2.35019 times 10 to the negative 10 electrons. So for the main physics principles involved, we have Coulomb's law, Newton's second law, and the force of gravity. Coulomb's law measures the electric force of attraction or repulsion between two separate charges, shown by this formula below. Newton's second law tells us that the net force applied to a system is directly related to the system's change in momentum, shown by these equations, and the force of gravity is the attractive force between objects. So for our initial conditions, we had a tape mass of 0.0002032 kilograms, tape length was 0.2 meters, tape width was 0.02 meters, the area of the tape was 0.004 meters squared. The area of one atom is 1 times 10 to the negative 20 meters squared, and the number of atoms within the piece of tape is 4 times 10 to the 17 atoms. And so here we have an image of our two pieces of tape repelling each other since they both have the same charge. And since the tape is positive and the pen has a negative that we rubbed against a cloth has a negative charge, we see these two attracting in this photo at the bottom. So to differentiate our system and surroundings, the system is the floating tape, and the surroundings, there's everything else within, outside, including Earth. And so we see in this video,
just keep taking photos, videos, everything. Just keep taking photos, videos, everything.
Since the tapes repel, we see
just record the distance.
The top tape.
Oh, between the two.
The charge overcomes the force of gravity, and so it repels and pushes the top tape up without touching it physically. So the distance between the floating tapes when we start to see the top tape float was 8 times 10 to the negative 3 meters. So to find the number of excess electrons, we first need to calculate the force of gravity, which we find by multiplying mass times the gravitational constant, which yields us 1.991 times 10 to the negative 3 newtons. And then from this, we set the magnitude of the electric force equal to the magnitude of the force of gravity. So that's equal to that. And then next, we'll calculate the electric charge using Coulomb's law. And then from this, we can find the number of electrons lost by taking the total charge of the tape, which is this Q value found in step 3, and dividing it by the magnitude of the charge of the electron. So this gives us 2.626 times 10 to the 11 electrons lost, and our ratio is the number of atoms versus the number of electrons lost. Next up, we have our GlowScript computational model, which gives us our ideal values for this experiment. And so we find that the charge on the piece of tape is 3.765 times 10 to the negative 9 coulombs, and our ratio, there are about 1.7 times 10 to the 7 atoms for every electron lost on one piece of tape. And so our actual outcomes varied slightly from our predicted outcomes. This result can be explained by two main sources of error. One being the uneven charge distribution across the tape, since we assumed this was all equal, but in reality it's likely not. And then second, the loss of charge during all the handling of the tape. As the tape will gain more electrons back as it tries to neutralize its charge as we touch it and handle it in its environment. So what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and the other charged objects? So the answer to this is nothing. The pieces of tape would now be negatively charged, but since they both still have the same charge as one another, they would continue to repel each other and attract the pen. Next, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? The answer to this question is that the pieces of tape lose some of their charge when they touch items in their surroundings, in an attempt to neutralize the charge by gaining back their lost electrons.